Dear students, welcome to my new lecture. I am Rokhshana Parvin, lecturer, Department of Civil Engineering, World University of Bangladesh. This lecture content will cover consistency of soil, Atterberg limit, types of Atterberg limit, which are liquid limit, plastic limit, and shrinkage limit, and relations among liquid limit, plastic limit, and shrinkage limit. Consistency of soil. By consistency is meant the relative ease with which soil can be deformed. Consistency denotes the degree of fineness of soil, which may be termed as soft, firm, stiff, or hard. In 1911, the Swedish agriculturist Sir Albert Moritz Atterberg divided the entire range from liquid to solid state into four stages, which are liquid state, plastic state, semi-solid state, and solid state. He said arbitrary limits, also known as consistency limits, are Atterberg limits. The Atterberg limits which are most useful for engineering purposes are liquid limit, plastic limit, and shrinkage limit. In figure we can see up to solid state, with the increase of water content, the volume of soil remains same. And next to solid state, with the increase in water content, the volume of soil also increases. A gradual increase in water content causes the soil to change from solid to semi-solid to plastic to liquid states. The water contents at which the consistency changes from one state to the other are called consistency limits or Atterberg limits. Sir Albert Moritz Atterberg was a Swedish chemist and agricultural scientist who created the Atterberg limits, which are commonly referred to by geotechnical engineers and engineering geologists today. The Atterberg limits are a basic measure of critical water contents of a fine-grained soil, is shrinkage limit, plastic limit, and liquid limit. These limits are expressed as percentage water content. In solid state, it is considered that soil has no or less amount of water. When water added to the soil, for a particular volume of water, soil becomes semi-solid, then plastic, and lastly remain in liquid state. This is the liquid state of soil, which is as like as a liquid paste, and this is plastic state of soil. Liquid limit LL. Liquid limit is the water content corresponding to the arbitrary limit between liquid and plastic state of consistency of soil. So we can say liquid limit is the boundary limit between liquid and plastic state. It is defined as the minimum water content at which the soil is still in the liquid state but has a small shearing strength against flowing. If we decrease water content slightly, the soil will become plastic. Plastic limit PL. Plastic limit is the water content corresponding to the arbitrary limit between plastic and semi-solid state of consistency of soil. So we can say plastic limit is the boundary limit between plastic and semi-solid state. It is defined as the minimum water content at which the soil is just begin to crumble when rolled into a thread approximately 3 mm in diameter. If we decrease water content slightly, the soil will become semi-solid. Shrinkage limit SL. Shrinkage limit is defined as the maximum water content at which a reduction in water content will not cause a decrease in volume of a soil mass. It is the lowest water content at which a soil can still be completely saturated. If we decrease water content slightly, the soil will become solid. The shrinkage limit is less frequently used than the liquid and plastic limits. Plasticity index IP. The range of consistency within which a soil exhibits plastic properties is called plastic range and is indicated by plasticity index. The plasticity index is defined as the numerical difference between the liquid limit and plastic limit of soil. So we can write plasticity index Pi or IP equal to LL minus PL, where LL equal to liquid limit and PL equal to plastic limit. Consistency index IC. The consistency index or the relative consistency is defined as the ratio of the liquid limit minus the natural water content to the plasticity index. So we can write consistency index IC equal to LL minus W divided by PI, where LL equal to liquid limit, W equal to water content, and PI equal to plasticity index. Liquidity index IL. The liquidity index or water plasticity ratio is expressed as the ratio of the natural moisture content minus its plastic limit to the plasticity index. So we can write liquidity index IL equal to W minus PL divided by PI, where W equal to water content, PL equal to plastic limit, and PI equal to plasticity index. Here is an example. Let's read the question. A soil sample has the following properties. Liquid limit equal to 45%, plastic limit equal to 25%, shrinkage limit equal to 17%, water content equal to 30%. Calculate the consistency index. That means we have to calculate IC. Let's try to solve the question. We know consistency index IC equal to liquid limit LL minus water content W divided by plasticity index PI. Here from question it is given that liquid limit equal to 45% equal to 0.45, plastic limit equal to 25% equal to 0.25, shrinkage limit equal to 17% equal to 0.17, and water content equal to 30% equal to 0.3. Finally, replacing all values in this equation, we get consistency index IC equal to 0.75, and in percent it is 75%. And this is the end of our today's lecture. Thank you everyone.